Somewhere inside the training runs of the world's most advanced AI labs, there's a number nobody wants to talk about, a point where feeding a model more data stops making it smarter and starts making it worse. Not slower, not more expensive. Worse. And the terrifying part? A lot of that damage is invisible in the metrics everyone's watching. It's hiding in the one place nobody's checking. I'm going to show you exactly where that line is, why crossing it is happening right now across the industry, and why the smartest labs in the world just quietly reversed course. In 2020, OpenAI discovered something that looked almost too clean to be true. Plot a model's loss against its data, its size, and its compute on a log-log scale, and you get a near-perfect straight line. A power law, predictable, provable, bettable. This single chart is arguably the most consequential graph in the history of the tech industry. It's the reason $100 billion bets got made. The math said, pour in more data, get out more intelligence. Guaranteed. Let me explain what just happened here. Imagine you're learning to cook. The first 10 hours make you dramatically better, the next 10 hours less so. Eventually, you're grinding for tiny gains. That's how most learning works. It slows down, it hits walls, it flattens out. That flattening is what everyone expected AI to do too. But when OpenAI plotted the loss curve on a log-log scale, the line didn't bend. It didn't flatten, it just kept falling. Straight, clean, predictable. Across 10 orders of magnitude of compute. That line is why $100 billion bets got made. The math wasn't just promising, it was provable. You could calculate how good a model would be before you even built it. Nobody fully understands why the line stays straight, but it does. And that changed everything. But 2 years later, DeepMind went back and checked the receipts, and what they found should have set off alarms everywhere. They discovered that almost every major model at the time, including GPT-3, was being trained wrong. Not a little wrong, fundamentally miscalibrated. There's an optimal ratio between how big a model is and how much data you feed it. Close to 20 tokens for every parameter. Blow past that ratio without scaling the model itself, and you're not buying intelligence anymore. You're buying a bigger number on an invoice. That was warning number one. It gets worse. Here's what nobody saw coming. The internet AI models train on is no longer purely human. A growing share of it is now written by AI, meaning new models are increasingly learning from the output of old models. Sometimes their own. This has a name. Researchers call it model collapse, and once you understand the mechanism, it's genuinely unsettling. Every model generates text by sampling from a learned probability distribution. That distribution is never a perfect mirror of reality. It slightly underrepresents the rare stuff. Unusual phrasing, niche facts, minority viewpoints, the outliers. Train a new model on that output, and you're learning from a distribution that's already lost a sliver of the truth. Do it again. And again. Each generation, the rare, weird, true edges of human knowledge quietly erode, while the model drifts towards something safer, blander, more average, more confident, less correct. A 2024 study in Nature proved this happening in real time. Recursively trained models degraded sharply on rare, high-variance cases, while their performance on common, everyday cases looked completely fine. Listen to that again. The failure was invisible on the metrics everyone checks, and catastrophic on the ones nobody does. That means a model could be quietly rotting from the inside, passing every benchmark you throw at it, while losing its grip on exactly the edge cases where being wrong actually costs something. Rare diseases. Uncommon legal precedent, minority languages, the stuff that isn't common enough to show up in an average, but is exactly the stuff you needed the AI to get right. Now here's the third failure, and it's the one that should make any technical viewer's stomach drop. When the same data shows up too many times in a training set, duplicated pages, viral posts, scraped 100 times over. A model stops learning from it and starts memorizing it word for word. Researchers at Google and Cornell proved this directly. Large language models can regurgitate near verbatim chunks of their training data, and the more times a sequence appeared in training, the higher the odds it gets leaked back out. That's not a hypothetical. That's a documented, measurable privacy and IP failure mode sitting inside models deployed right now. And there's a second, quieter danger hiding in the same mechanism. These models are trained to predict the most likely next word, not the most true one. If a biased or flat-out wrong idea appears often enough in the data, it starts looking statistically identical to a fact. The model has no internal alarm that goes off to distinguish repeated a lot from actually correct. More unfiltered data doesn't dilute that problem. It hands the model more ammunition to be confidently wrong. So while everyone else kept scaling up, a few labs did something almost nobody expected. Microsoft's Phi team took a much smaller model, fed it a small, ruthlessly curated set of synthetic, textbook-quality data instead of raw internet scrape, and it matched, sometimes beat, models many times its size on reasoning benchmarks. Let that sink in. Less data, better results. That's not a fluke. That's the entire scaling story flipping in real time, the compute optimal ceiling from Section 1, the recursive erosion from Section 2, the memorization and bias amplification from Section 3. All three point at the same conclusion: past a certain threshold, raw data volume stops being the asset. It becomes the liability. The next generation of AI isn't going to be won by whoever scrapes the most data. It's going to be won by whoever can tell the difference between a token that teaches the model something and a token that's quietly poisoning it. And right now, most of the internet can't tell you which one you're looking at. If you want to actually understand how these systems work, not the headlines, the mechanics, subscribe. Because this is only the beginning of what's breaking under the hood of AI right now.